5 cardboard boxes entered the forward cargo hold of ValuJet Flight 592 as company aircraft material. The shipping ticket described their contents as empty oxygen canisters. They were not oxygen tanks, and they were not empty. Inside were more than 100 chemical oxygen generators, devices designed to become hot while producing oxygen for emergency passenger masks. 1 or more generators activated after loading began. The exact unit and moment were never established. Inside the restricted ventilation hold, the reaction supplied heat and its own oxidizer. The compartment had been certified to control a normal fire by limiting fresh air until available oxygen fell. These devices could continue making oxygen for as long as 20 minutes. Flight 592 left Miami for Atlanta with 110 people aboard, 2 pilots, 3 flight attendants, and 105 passengers. 1 4-year-old child traveling as a lap passenger did not appear on the passenger manifest, a separate accounting issue the investigation later addressed. For about 6 minutes after takeoff, the cockpit received no cargo fire warning because the Class 500 hold had no detector and no built-in suppression. The first signs were an unidentified sound, electrical trouble, and reports of fire from behind the cockpit. The crew turned back toward Miami as systems and controls began failing. 10 minutes after takeoff, the DC-9 struck the Everglades 17 miles northwest of the airport. There were no survivors. The impact left few large components and forced investigators to recover small fragments from water, mud, and sawgrass. The National Transportation Safety Board traced the fire through maintenance cards, uncapped generators, shipping labels, cargo compartment rules, controlled burn tests, and the few seconds of data that remained before impact. Much of the causal record had survived outside the aircraft before the flight even began. How did emergency equipment labeled empty pass through maintenance, stores, shipping, ramp acceptance, and the aircraft door without anyone treating it as hazardous material? The devices left the cabin without their shipping caps, remained on a maintenance floor without a controlled destination, entered boxes under a misleading description, and reached a hold built around declining oxygen. Each move was ordinary. Their combination was not. Chemical oxygen generators were built for a familiar emergency. If cabin pressure fell at altitude, masks would drop above the seats. Pulling a mask toward the passenger removed a small retaining pin in the overhead unit. That mechanical action started the device. No oxygen bottle had to be opened. Inside the cylinder, a spring-loaded striker hit a percussion cap containing a small initiating charge that started decomposition of a sodium chlorate-based core. The chemical reaction released oxygen into the mask tubing. It also released heat because oxygen generation and cooling were not separate processes inside this compact device. When normal service, the generator sat inside a metal housing above the seats, surrounded by components designed for its heat. Manufacturer data put typical shell temperatures around 450 to 500 degrees Fahrenheit, with a specified maximum of 547 under stated conditions. Oxygen output could continue for 18 to 20 minutes, long enough for an emergency descent. A generator could reach the end of its 12-year service limit without ever activating. Expired meant its reliability for emergency use was no longer assured. It did not mean the chemical core had disappeared. Unless the device had been expended, its pin, striker, percussion cap, oxidizer, heat, and oxygen-producing capacity remained. Shipment required a different physical state from installation. An unexpended, removed generator needed a safety cap over the percussion cap region. The cap prevented mechanical contact from driving the activation system. A loose lanyard also had to remain secured. Tape wrapped around the cylinder could hold a cord against the body, but it did not shield the striker area like the specified cap. The generators aboard Flight 592 did not come from the accident DC-9. They had been removed from 2 MD-80 series aircraft undergoing work at Sabertech's Miami facility. That distinction matters because the items moved from one aircraft program into another through a maintenance and shipping system. They were cargo, not installed equipment on N904VJ. Approximately 144 generators were removed. Mechanics reported about 6 as expended. The records did not show that the remaining roughly 138 had been discharged. This was not a quantity that appeared later through forensic guesswork. The workstream had produced a large inventory of small active capable devices that needed caps, identification, and controlled disposition. One device was small enough to hold in a hand. A box contained many. Each generator carried its own oxidizer, so one activation could heat surrounding packaging while raising the oxygen concentration around it. Nearby units did not need an external oxygen bottle to sustain the environment. The danger came from grouping active capable generators without the protections required for transport. Work Card 0069 governed removal of the generators from the donor aircraft. Mechanics used it at the worksite and inspectors signed against it. The card explicitly told them to install a shipping cap on an unexpended unit. It did not include the maintenance manual's later direction to place removed units into storage or disposal. A capped generator could be handled safely for shipment. A documented destination would keep it inside a known material control system. The job card required the first safeguard and omitted the second, leaving completion possible even when the object still had nowhere controlled to go. The caps were not available in the work area, and they were not installed. Several retaining pin lanyards were taped around the cylinders instead. Tape kept a loose cord close to the body, but left the percussion cap region exposed to contact. Mechanics attached green repairable tags to many units and used a smaller number of white removed or installed tags. On the maintenance floor, those colors belonged to an internal parts vocabulary. None of them established that the chemical core had been expended or that the device was safe for air shipment. Relevant work cards were signed as complete, while the safety cap requirement remained unmet. A signature normally closes a maintenance task and tells the next person that each required step has been performed. Here it converted an obvious unfinished condition, rows of uncapped generators, into paperwork that appeared resolved. The NTSB treated the false or inaccurate entries as serious failures while distinguishing among mechanics, shifts, and conflicting recollections. The key state was visible in the objects and hidden in the records. The caps were absent after the cards said the work was complete. A ValuJet technical representative later testified that he saw uncapped generators, warned that they were hazardous if activated, and asked for hazardous waste handling. Other witnesses remembered parts of that exchange differently. The NTSB recorded the conflict rather than selecting a private conversation it could not reproduce. The condition afterward was clear. No caps appeared, no disposal record followed the units, and the boxes remained on the facility floor. Whatever had been said never became a physical correction that the next shift could rely on. Sabertech's Miami facility was under heavy workload as several aircraft moved through modification and maintenance. An April memorandum called for employees, including management, to work 7 days a week. One mechanic described 12-hour shifts across that schedule. Long hours can narrow attention and make incomplete work easier to carry between shifts, but the board did not name fatigue as a separate probable cause. The documented failures remained the missing caps, inaccurate records, weak material control, and insufficient supervision around work performed under pressure. After removal, the generators occupied a space between maintenance, stores, and shipping. They were no longer installed equipment, yet they had not entered a controlled hazardous material or disposal stream. Green repairable tags told a trained maintenance worker that a part still needed action. A stock clerk without generator training could read the same tag as permission to treat the item like ordinary reusable inventory. The metal cylinders stayed the same while their practical meaning changed at the doorway between departments. The mechanics knew that pulling a pin could start the generator. Stores personnel needed to know that an unexpended unit required controlled handling. Shipping needed an oxidizer description, approved packaging, hazard markings, and the correct papers. ValuJet needed that same information before accepting the boxes as company material. Instead, the work card said complete, the green tags suggested repairable parts, and the missing disposal step left the cylinders available for ordinary shipment. By the time the boxes reached the ramp, the decisive technical facts had disappeared from view. In early May, the facility prepared for a possible customer audit. Shipping and receiving needed to clear boxes from the floor. The generators had been sitting there through the unresolved maintenance handoff, taking up space as objects that looked tagged but lacked a destination. A stock clerk proposed closing the 5 boxes and sending them to ValuJet in Atlanta. The cleanup instruction did not order hazardous material onto an airplane. It created a deadline for deciding what the boxes were, and the available records pointed toward ordinary company parts. The stock clerk opened and redistributed the generators, laying the cylinders end to end. 2 or 3 inches of bubble wrap went above them before the cartons were sealed. That packaging kept the objects together but did not isolate exposed activation areas or prevent contact with retaining mechanisms. The boxes received aircraft parts and company material labels. They carried no oxidizer marking, hazardous shipping description, or required papers. The clerk later said he did not know what the objects were and relied on the information the tags seemed to provide. The shipping ticket described the contents as oxy canisters, misspelled, with empty placed in quotation marks. The clerk said he inferred the description from the green tags. Empty now traveled on a formal document beside the boxes. It could mean a canister without compressed gas, a spent generator, or simply an object no longer installed in an aircraft. Only one of those meanings would make the shipment appear harmless. No accompanying record corrected the ambiguity. On the morning of May 11th, a Sabertech driver delivered 5 boxes and 3 aircraft tires to the ValuJet ramp. Evidence later indicated that 2 of the tires, rather than all 3, had wheel assemblies. Each generator box weighed roughly 45 to 50 pounds, substantial but ordinary for aircraft material. Ramp employees handled the boxes and tires as cargo. The lead agent took the shipping ticket to the first officer for approval, then the material went into the forward compartment with passenger baggage. The ramp agents saw boxes of company material and tires without hazard markings. The first officer saw the shipping ticket describing empty canisters. Neither perspective supplied evidence of active oxidizers. The NTSB found their acceptance was not unreasonable given the information presented. A rejection would have required someone at the ramp to recover technical facts that maintenance, stores, and shipping had already removed from the paperwork. The forward hold door closed within about 5 minutes of loading. The generators were now inside a 560 cubic foot Class 500 compartment beneath the cabin floor. No one knew which device, if any, had already lost a retaining pin. Investigators could only conclude that one or more activated after loading began, possibly as late as the takeoff roll. A Class 500 cargo compartment used passive protection. Fire-resistant liners and separation were meant to keep smoke, flame, and dangerous gases away from occupied areas. The volume was limited and ventilation stayed low. For ordinary baggage fires, combustion would consume the oxygen already present faster than outside air replaced it. Heat might damage cargo, but the fire was expected to stop growing before it threatened the aircraft. Under that premise, a contained low ventilation space could provide safety without an active extinguishing system. Certification treated the self-limiting fire as the warning and suppression strategy. Class 500 therefore carried no requirement for a cockpit smoke detector or a built-in extinguishing system. Class 100 used both. Flight 592's forward compartment met the Class 500 rules then in force, so its crew had no dedicated light or alarm identifying smoke beneath the cabin floor. The first indication would have to come from something the fire had already affected, such as wiring, structure, a tire, smoke entering occupied space, or people who could see the conditions. A chemical oxygen generator changed the compartment's oxygen balance. The sodium chlorate core carried the chemistry needed to release oxygen after activation. Its hot shell could ignite nearby packaging while the same reaction enriched the air around the flame. As ordinary combustion consumed oxygen, active generators could replace part of it. Lower ventilation then trapped heat and smoke around a source that the Class 500 model expected to weaken. The compartment still contained the fire physically, but its central method of limiting growth had lost control of the fuel oxidizer environment. Bubble wrap sat above the cylinders. Tires and passenger luggage occupied the compartment around the 5 boxes. Movement during transport or loading could change contact between the uncapped devices, their lanyards, packaging, and adjacent objects. Investigators could not establish the exact arrangement at activation, the first pin removed, the first generator started, or the first material that burned aboard the aircraft. The available geometry still supported a dangerous range of possibilities. One hot unit could ignite packaging inside an oxygen-enriched box, damage neighboring units, and spread fire into the surrounding cargo. Warnings about Class 500 had existed before Flight 592. After a 1988 cargo fire on American Airlines Flight 132, the NTSB recommended smoke detection, fire extinguishment, and evaluation of restrictions on oxidizers in compartments lacking those systems. The FAA later told the board it did not consider the proposed detection and suppression rulemaking cost-beneficial and terminated that effort. The NTSB classified the recommendations as closed with unacceptable action. Class 500 remained an approved category on passenger aircraft when the ValuJet boxes reached Miami. The Class 500 analysis assumed baggage, ventilation, and a limited supply of air. The actual load included dozens of devices capable of producing oxidizer and several hundred degrees of heat. A shipping label could control how people handled the boxes, but it could not change the reaction after a pin moved. By the time the DC-9 began climbing, emergency equipment built to protect passengers during decompression may have been creating the condition that passive cargo protection could not limit. Flight 592 was cleared for takeoff at 2 hours 3 minutes and 24 seconds. The DC-9 climbed west, then north from Miami toward its route to Atlanta. At 2 hours 4 minutes and 32 seconds, the crew checked in with departure control and received clearance towards 7,000 feet, then higher along the wind code transition. Radio calls and recorded engine data described a routine climb. Below the cabin floor, the generators were outside the crew's view, and no sensor could distinguish a box warming at the gate from one activated by handling, taxi, or takeoff vibration. At 2 hours 10 minutes and 3 seconds, the cockpit voice recorder captured an unidentified sound. The aircraft was at 10,634 feet and 260 knots. Investigators considered the sound and a pressure change in the flight data most consistent with an inflated tire rupturing after fire damage. The tire was a consequence inside an already developing fire, not the ignition source. 12 seconds after the unidentified sound, the captain reported an electrical problem. He then said the aircraft was losing everything. Voices from the cabin called out fire, and the crew requested an immediate return to Miami. They had to reverse a climbing departure, descend, receive a runway and headings, manage smoke and electrical loss, and keep control of an aircraft moving at 260 knots. Peak recorded altitude was 10,879 feet at 2 hours 10 minutes and 31 seconds. The descent began soon afterward. The crew's first direct awareness arrived after the fire had already damaged the aircraft. A cargo detector would have warned on smoke before a tire rupture or widespread electrical effects became the messenger. A built-in suppression system could have attacked the surrounding fire and reduced its growth, even though the board did not claim it was certain to overcome every active generator. Flight 592 offered neither defense. The crew began its return only after heat had already shortened the time in which a landing remained possible. Smoke was reported in the cabin, and a small amount entered the cockpit before the last recorded crew statement. A flight attendant described severe fire conditions. The pilots asked for the closest airport and received vectors back toward Miami, where long runways and emergency services were available. The descending turn placed more control demands on an aircraft whose wiring, floor structure, and control paths near the forward hold were being damaged by heat. It was still moving at about 260 knots, while the usable systems were shrinking. At 2 hours 12 minutes and 48 seconds, the flight data recorder stopped. Its last values were 7,200 feet, 260 knots, and a heading of 218 degrees. Radar transponder returns continued. Controllers kept issuing approach instructions, but no intelligible reply came back. The loss of recorded data marked a system failure, not the moment the aircraft struck the ground. The NTSB found that final loss of control most likely resulted from flight control failure caused by extreme heat and structural collapse. Smoke or heat incapacitating the crew during the final 7 seconds could not be ruled out. The evidence supported a likely mechanical path while preserving a second possibility it could not eliminate. Flight 592 struck the Everglades at 2 hours, 13 minutes, and 42 seconds in a steep, right wing down, nose down attitude. 1 second later, a controller transmitted that Opa-locka Airport lay about 15 miles ahead. The timing matters. The message did not present an airport option that the crew heard and ignored before impact. The wet sawgrass and limestone made recovery unusually difficult. The crater filled with water, and search teams worked through a grid to recover human remains, recorders, aircraft structure, and cargo fragments without a conventional field of large wreckage. Investigators cataloged small pieces and compared them with maintenance records, cargo documents, and controlled tests. The violence of impact limited direct evidence of the first fire sequence. The pre-flight record was more intact. Work cards, tags, shipping papers, testimony, compartment drawings, and the known chemistry of the generators could still be placed in order. Early configurations examined boxes of generators and bubble wrap. The final test added surrounding luggage and a pressurized main gear tire. Investigators deliberately pulled a retaining pin to start a known device. The chamber held about 2,357 cubic feet, more than 4 times the volume of Flight 592's forward hold, and its door remained open for filming. The tests isolated physical behavior under documented conditions rather than recreating the unknown arrangement aboard the aircraft. In a repeat one-box test, bubble wrap touching a hot generator auto-ignited in the oxygen-enriched space. Temperatures inside the box reached about 2,000 degrees Fahrenheit after 10 minutes. A repeat 5-box test reached about 2,000 degrees above a box near 13 minutes and rose toward 3,000. In the final configuration, a ceiling sensor exceeded its 200-degree measurement range after roughly 11.5 minutes. The tire ruptured later at 16 minutes, supporting the idea that the recorded tire sound followed an established fire. Those temperatures belonged to the test chamber, not to sensors aboard Flight 592. Investigators lacked exact box dimensions, generator orientation, ventilation, tire arrangement, and initial activation count. The open test door changed the environment further. Even with those limits, the experiment connected known objects to plausible consequences. Uncapped generators packed with bubble wrap could create an oxygen-rich fire, reach temperatures capable of damaging aircraft structure and systems, and rupture a nearby tire after the fire was already underway. Recovery produced generator fragments, the flight recorders, and wreckage that could be arranged in a full-scale cargo compartment mock-up. Maintenance cards showed the cap requirement and the completed signatures. Tags and testimony traced how the units were handled. The shipping ticket preserved the description presented at the ramp. Flight data and cockpit sound constrained the fire timeline, while controlled tests demonstrated the heat and oxidizer behavior. The first pin remained unknown, but each independent record led back to the same boxes in the same compartment. The NTSB's probable cause named 3 responsible organizations and functions. Sabertech failed to prepare, package, and identify the generators properly. ValuJet failed to oversee its contract maintenance program. The FAA failed to require smoke detection and fire suppression in Class 500 cargo compartments. Those findings placed the boxes inside a larger operating structure. The last person who touched one was working within maintenance records, airline supervision, and cargo rules that had already failed to control the hazard. Contributing factors included weak FAA monitoring of ValuJet's heavy maintenance responsibilities and Sabertech's certificate, an inadequate response to earlier generator fires, and gaps in hazardous material understanding and training. ValuJet's rapid growth depended heavily on contract maintenance, which made the airline's own surveillance of outside work a critical safety function. The FAA also had to monitor both the carrier's program and the contractor performing it. Those oversight layers met the older Class 500 rule only after the boxes were already inside the forward hold. The regulatory response moved along 2 tracks. On May 24, 1996, the FAA issued interim action restricting chemical oxygen generators as cargo on passenger aircraft. A final prohibition followed on December 30th, effective December 31st. On June 5, 1997, new approval and shipping description requirements addressed the generators directly. On February 17, 1998, the FAA ordered passenger aircraft Class 500 compartments upgraded to Class 100 detection and suppression, with compliance required by March 19, 2001. Rules published in 1999 and effective in 2000 strengthened controls for chemical oxidizers. One track reduced the chance that an active oxidizer could enter a passenger hold under an innocent label, the other gave crews an alarm and an active means to fight a fire. Class 500 had been a legal certification category, and its passive logic could limit an ordinary fire in a small, low-ventilation space. Flight 592 brought a different chemical condition into that model. The generators released oxygen as they heated surrounding material, so the expected decline in combustion could be delayed or reversed. Reclassification to Class 100 changed the operational bargain. Smoke detection would identify a developing fire before secondary damage became the first warning. A built-in extinguishing system would attack the surrounding combustion while the crew diverted. Those defenses could not guarantee survival against every cargo fire, but they replaced an invisible assumption with information and action. The generators began as installed emergency equipment. After removal, green tags placed them among repairable parts. The shipping ticket called them empty canisters, and the COMAT label placed them among ordinary company cargo. The words became safer at each step while the device stayed capable of the same heat and oxygen from the maintenance bench to the aircraft hold. Ramp agents and the flight crew received paperwork for empty company material rather than active oxidizers. When the fire developed, the pilots learned through electrical loss and reports from the cabin because the hold had no direct warning system. Missing caps and misleading records brought the hazard aboard. Weak oversight and passive cargo protection left little opportunity to catch it afterward. Flight 592 is often described as a fire caused by expired oxygen canisters. The service date was less important than the physical state hidden by the word empty. The generators were unexpended, uncapped, chemically active, and shipped without their hazard description. When one or more started, the Class 500 hold restricted ventilation as intended, but the reaction continued supplying oxidizer. The paperwork had described harmless cargo. The chemistry and the compartment told a different story.